me again.
All right. So everyone should be able to see this. Just a quick overview of the notebook. We're going to talk about processing one single interferogram using Sentinel-1 data. This is essentially building on what Harish showed you yesterday about StripMap app. 90% of the workflow is the same, except one or two minor variations, and we'll highlight it when we get to the details. For this particular notebook, we'll be using data from the 15th May Monte Cristo earthquake in Nevada. This is a pretty interesting earthquake data-wise. I don't know about geophysics-wise, because this was imaged at least in 2 or 3 tracks with 6-day temporal sampling. And the area is small enough that you can actually go ahead and process the same interferogram with different geometries, with 6 days, with 12 days, and actually see the impact of post-seismic deformation and all that by combining the imagery. So for this notebook, we will be using this directory structure. This is the notebook, topsApp.ipanb. Support docs contains some figures that we use in the notebook. The other 2 folders will get created in the process in this notebook. One will hold the interferogram processing folders, and the other is the raw data download for the notebook. Also, I've organized the table of contents on the left. If you don't see it on your notebook, you can click on this table of contents button, and that should show up on the left. So if people are ready to get started, we will get going. All right, so this notebook is designed in a way that you always have to run this first cell. This automatically figures out which folder you are in and sets up the folders you need to run this. So I'm on my local laptop. It's in some folder. You will see the appropriate folder name on your machine. Like I said, the data set that we're using, so people are, if you're not able to see the table of contents, go to your Jupyter Lab, click on your NB extensions, click this, and you should probably see a table of contents here. Select that. Go back to your notebook, stop it, then restart the notebook, and you should see a button pop up here that you can pull up. This basic process applies for enabling any of the other extensions as well if you need it. All right. So like I said, we're going to talk about the Monte Cristo earthquake. I put in a link for the USGS event page here. You can get more information on the event there. We're looking at a 6-day pair, and this is over Nevada, which is a fairly dry region. So this is a very coherent data set, but it's a good data set to like I said, to understand the processes and what happens, the projection of deformation into line of sight, and so on. I've also put in a link to the ASF Vertex search page. So that's essentially the data set that we're going to use. So you should be able to just use that link and download the 2 images you need onto your own machine for playing with it if you want to play with the data set locally. Yeah, so let's jump into the TOPS mode processing. So what is TOPS mode processing? How is it different from StripMap processing? So yesterday, Harish spoke about the StripMap mode where the satellite is flying along and it's looking with a fixed pointing to the side. TOPS is a strategy that was developed to allow the satellite to view a much wider area. So what the satellite does is, as it's flying along, it's rotating and scanning. It's going, it makes a scan, creates an image for one part of a swath. Then it scans the next swath, then jumps to the next swath, and then goes back to swath 1. So what it's forming, instead of forming one continuous image, it's taking multiple pictures and covering the entire area as a collection of pictures instead of one contiguous picture, as happens in strip map. So essentially, what that means is we end up, when we download a Sentinel-1 TOPS mode SLC, we are not downloading one single image. We are downloading a collection of images. Each image is small, but you are able to put it together to build a much larger image. So the workflow that we're going to look at today essentially will apply the same sort of strip map methodology we saw on a tiny image by image basis. And then it combines all these image by image interferograms into a big merged interferogram. That's essentially the main difference. Technically, it's almost all the same processing, except there's extra bookkeeping because you want to know where these tiny images are relative to each other in space, so that you're able to mosaic them and merge them together into a bigger image. Any questions so far on Sentinel-1 and what the data SLC format looks like? So a typical Sentinel scene would be 250 kilometers by 250 kilometers. It could vary. I've seen 100 kilometers by 250 kilometers, but in the range direction, it's always 3 swaths in the IW mode and about 250 kilometers. Each burst by itself is only about 20 kilometers long. So typically you will see 12 bursts or 13 bursts. In some cases, there are also only 5 bursts at the end of a data take and so on. But these tiny images are 20 kilometers by 80 kilometers roughly, which means these are really wide images. Next, what we're going to do is like I said, I already gave you the link to the ASF page. We're going to download the imagery for this notebook, and I'm going to use Sasara to do this. I kind of use Sasara for everything nowadays, DEMs, orbits, so on. If you already have Sasara on your command line, you don't need to do this. But if you don't, you can always make a local copy. It's not a heavy folder. I already have it, which is why it's showing me this error. If you don't have it, it'll download it. This is just to make sure that you actually got Sasara. In that, yep.
Just a reminder, at some point you have to do the 8-core, the 8-thread command.
Yes, okay. I will add that in. Perfect. Thanks for the reminder. I had forgotten it. Just before we start processing, we'll do that for sure. I'll remember to do it. Okay. So for this particular data set, I can build a query with Sasara like this. I'm like, so it's Sentinel-1A, 1B, relative orbit is 71. These are the start date, end date, and I've given the polygon it should intersect the ground, and I'm asking it to print. I'm not asking it to download. So when you run this command, it should print it. It should give you the 2 URLs you need for downloading. You can copy the URLs into the files list. You can set your own username and password. If you see my old username and password in your notebooks, don't worry, that doesn't work. The password is fake. So please feel free to change it to your username and password and hit this button. If you have not already downloaded the data, this will start a download. You should, this might take a couple of minutes for it to go fetch the data from ASF. Once you've done downloading, when you see a number next to the cell, that's when you know the data has been downloaded. You can verify by just running the ls directory name, and you should see 4 GB files next to it. Ignore this. This was some temporary thing, but you should see 2 zip files that are 4 GB. If you are having downloading issues, we also have put in a copy in the S3 bucket, and I have a function called copy from bucket that should let you pull the data in case someone has trouble with downloading the SLCs. Just give people 2 minutes to download. While it's downloading, I'll talk a little bit about the file names used by the Sentinel-1 system. So the products you see will have file names like this. S1A indicates it's an image from Sentinel-1A. If it's 1B, it's 1B, 1C and 1D will be up soon. IW indicates the imaging mode. This is the TOPS interferometric mode. SLC says this is an SLC. The other product is GRD. That does not contain phase information. You should not download GRDs to do interferometry. SDV says this is dual polarization VVVH. If you see SDH, it's dual polarization HHHV. If you see SSV, it's single polarization VV imagery. All of this is documented on the InSAR webpage. I'm just going through this really quickly just to give you a quick overview. Then the next thing you'll see is the time tag. It's the date up to the second of the acquisition, which is the first line of the SLC, the satellite time corresponding to the first line of the SLC. This corresponds to the up to the second time tag of the last line of the SLC. And I believe the rest are production fields that we don't really need to worry about. This last 4 characters is a unique hash. So if a SLC for some reason is regenerated by InSAR, this last 4 characters are guaranteed to be different, even though the rest of the file name may appear similar. Any questions about downloads? Anyone having trouble? Because once we have the imagery, the one other piece of information we need to process Sentinel-1 interferograms is the orbits. So we can use Sesara to download the orbits as well. So you can go back to the tutorial directory, run the Sesara command, and this will go fetch the orbits required for you. The other thing I find very useful is it will also print a DEM thing. So if you want to build your own DEMs from Open Topography, you can just copy paste that line and run it, and you should be able to get that as well. So once we download the orbits, we just tuck it away into the orbit folder. I'm on my local machine. I have a whole bunch of orbits sitting, but you should only see 2 orbit files, these 2 ones that you just downloaded in your folder. Again, for people who are having trouble with downloads, there is a copy of the orbit file sitting in the buckets. You should be able to run this and pull in the orbit files if needed. There is one more input you may need. It's really not needed anymore. It was very early in the mission. There were a few processor versions that needed some additional instrument corrections. I believe most of these have been reprocessed, so you never really have to get instrument calibration file. But if you, for some reason, have to go back and play with this data, the instructions to get this file are included in the example input files. We're not going to go through this because this really impacts a very tiny, small fraction of the data. So if people are ready to go with the downloads, this might be a good place to put in a number of threads. So this line is missing from your notebooks. I would like all of you to put in this line so that we don't run into issues like we did yesterday when running some of the processing steps, the computationally intensive steps. So,
the chat.
Yeah, I can put that in chat. If people did manage to enable the table of contents, and if you're seeing weird numbering here, one thing you can do is you can go there and turn off the automatic number headings. That way it will pull in whatever heading you put in for numbering.
There's a question on aux files, Piyush.
Mm-hmm.
Did you see that in the chat?
Let's see. Yeah, the aux files are no longer needed. They're only essentially for very early processor versions, and especially this one particular processor version with data. I think that processor version was only used for 2 months fairly early on in the mission, and a lot of it may have been reprocessed already. If you do provide an aux file for all of them by default, that will not cause any failures. It'll just say that it'll look at the processor version and say, I don't really need to use the aux file, and it'll skip it. I've also included links to where these input files sit on the ICE2 repo. Essentially, just like what Harish showed yesterday, it's pretty much similar structure. You need 3 XML files. One to control the topsApp workflow, one to provide information about the reference image, and one to provide information about the secondary image. And we'll go through them one by one.
Before you go on, can we verify one more time? So please make sure that you have set the environment variable. If you don't know what that means, raise your hand or look in the chat. There's a line that needs to be added to the notebook. It's section 1.5.
So one of the questions is some orbits are P or RB and one are res orb. Precise orbits typically are released about 21 days after flight because you need a long GPS arc to correct for minor tidal effects. They are precise orbits. The res orb is the restituted orbits, and that comes out about 6 hours after image acquisition. The difference between them is on the order of a couple of centimeters. For most practical applications, it almost makes no difference because the restituted orbits are really very good quality for Sentinel-1.